Yes, hello everyone, and welcome to the 6th International Project and Construction Management e-conference. It's quite unfortunate we couldn't have the physical conference, but I hope everyone is safe and fine. My name is Bello Zailani from Bello University, Nigeria, and I am presenting a paper on the moderating effect of team absorptive capacity between complexity and quality performance in construction projects. Globally, construction projects are often regarded as complex projects, largely due to the number and heterogeneity of different elements that interrelate in such projects. We often find a quite number of diverse individuals with diverse professional backgrounds working together on construction projects to achieve project success. More so, there is an enormous number of tasks involved in construction projects that interrelate to solve the whole project. As such, complexity is often regarded as an inherent characteristic of projects, and such projects are often termed as complex projects. So you find studies that regard construction projects as complex projects due to the nature of heterogeneity and the number of tasks involved in them. However, this complexity in projects is often assumed by many scholars and practitioners to have a negative effect on project management performance. Based on this, various constructs have been used in studies over the years to find a moderating effect or to find how to moderate the negative effect of complexity on project management performance. One of such constructs is absorptive capacity, which stems from the broad organizational management literature that deals with the ability of the project team to acquire knowledge, assimilate it, transform it, and exploit it for project use and also to improve the project performance. Evidently, the professional diversity in construction projects represents a palette of novel perspectives that need to be assessed, assimilated, and applied by the team collectively. In 2018, Yelverton and Wild established a positive moderating effect of absorptive capacity between complexity and project time and cost performance in a study. However, project management literature has noted that project management performance is typically measured in terms of three dimensions, being cost, time, and quality. The study carried out by Yelverton and Wild adopted a reductionist approach to maintain model parsimony and only assess project management performance based on two dimensions, being time and cost. This creates a gap in defining the overall effect of absorptive capacity on project management performance. And as such, this study complements the finding of that study by assessing the moderating effect of team absorptive capacity on the third dimension of project management performance, which is quality performance. The study adopted a quantitative research approach using a structured questionnaire to elicit perceptual data from respondents with regards to the projects that were involved in on three issues or three constructs of the study, being absorptive capacity, project complexity, and project quality performance. The questionnaire was structured into three sections, asking the perceptions of them with regards to the three constructs of the study. Purposive sampling was adopted and data collected was analyzed using both descriptive and inferential statistics. Partial least square structure equation modeling was used to test the causality between the three constructs in the study. As with most studies, an in-depth literature review was carried out and research hypotheses were developed to develop the structural model. The model consisted of three main variables. The model consisted of three main variables being project complexity, quality performance, and absorptive capacity. Project complexity here being the independent variable, quality performance being the dependent variable, and absorptive capacity being the moderating variable. The measurement models for project complexity and project quality performance were both reflexive, while the measurement model for absorptive capacity is formative. The next few slides will give an in-depth review of the data collected and the analysis, and also give highlights on the results found. Characteristics of respondents and nature of projects involved were asked to define the parameters of the study, findings, and enable interpretation within the context of the data collected and analyzed. It is important to contextualize the findings of the study so that it will be used in interpreting the findings of the study. Functional roles of the respondents performed was asked, and a large percentage of the respondents were performed architectural roles on the project. Project management had 13%, quantity surveying 22%, structural engineering 11%, and service engineering, which involved mechanical and electrical engineering, having 5% representation. Team size of the projects that the respondents were involved in was also inquired. Majority of the respondents responded participating in the project team that consisted of numbers ranging from 5 to 10 members, while less than 5 members represented 10% of the response, and 11 to 15 members represent 5% of the response. None of the respondents was involved in a project that had more than 16 members. Also, the type of project that were involved in with regards to public and private nature of the project was asked. Majority of the respondents reported participating in public projects, and as such, the findings of this study should be reflected with regards to this context of the data. Measurement scales were designed to measure each of the study constructs, and respondents were asked to rate the application of these measurement items in respective projects that were involved in. Absorptive capacity was measured using 8 measurements, as you can see from here. Complexity was measured using 4 measurement items, while project quality performance was measured using 6 measurement items. It is important to note the nature of the questions that were asked to better understand the causality of the constructs. Negative questions formats were used for both complexity and performance. As you can see, questions like it was difficult to communicate information across projects with minimal loss in transmission, and also construction materials were not specified based on durability of the properties. However, positive questions such as important knowledge was transmitted regularly to all project participants were used for the absorptive capacity measurement. Reliability and validity of the model was measured to attest how good and robust the model is and how well it can be used to improve knowledge and ascertain show the moderation of the key constructs. Cronbach alpha, composite reliability, and Hessler's RHO measures of internal consistent reliability were used to assess the reliability of the model. All values were above the threshold of 0.7 as such model. All values were above the 0.7 threshold as specified by here at all, and as such we can attest that the model is quite reliable. Also, the validity of the measurement scale is the ability of the the measurement items to measure the constructs as they should. The AVE, which is the average variance extracted, was used to attest the validity of the model. As a rule of thumb, these ratings are supposed to be above 0.5. And as you can see here, we have values that are above 0.5, and as such, we can attest that the measurement items did actually measure the constructs, and as such, the findings of this study is quite reliable and the model is quite valid. This table here shows the path coefficients of the model, and it shows the causality, the causal relationship between the three key constructs of the model being absorptive capacity, quality, performance, and complexity. The path coefficients, which are values ranging from -1 to +1, often define the magnitude of correlation, with -1 being strong negative relationship and +1 being strong positive relationship. From the table, we can see the path from absorptive capacity to quality performance having a beta value of minus 0.29, which shows a very weak relationship between absorptive capacity and quality performance. The path from complexity to absorptive capacity had a beta value of minus 0.69, which shows a strong negative relationship between complexity and absorptive capacity. While the path from complexity to quality performance had a positive beta of 0.51, which shows a strong influence of complexity on quality performance of the project. Generally, we can use this data to interpret the findings and to show that project complexity largely influences project quality performance and also limits team absorptive capacity. With a view to attest the main finding of the study, we looked at the indirect parts to see how absorptive capacity has the potential to moderate this strong influence of complexity on quality performance. And as you can see, the complexity, the indirect path from complexity to quality performance through the absorptive capacity reported having a beta value of 0.218, which shows a significant difference from the 0.518 that we got from the direct path of complexity and quality performance by about 0.3 beta value. And as such, we can attest that absorptive capacity has the potential to moderate the direct effect of quality, a direct effect of complexity on quality performance in construction projects. The R-square values the R-square value is used to test the accuracy of the structural model and is often regarded as values that define whether the model is accurate, or not. These values are often required to be above the threshold of 0.3, and as you can see, the R-square values of the independent models that we have, the two independent models, quality performance having R-square value of 0.56 and the moderating variable having an R-square of 0.4, and as such we can attest that the model or the causality is quite accurate and it reflects the findings of the study. This diagram here presents what I just explained. From the causality of the relationships, you can see the direct path from complexity to quality performance having a path coefficient of 0.518, while the direct path from complexity to absorptive capacity having a path coefficient of 0.699. And when we did the moderation, when we did when we assessed the indirect parts, we had the direct part from complexity reduced to 0.28, which shows a moderating effect of absorptive capacity between complexity and quality performance. Summary of hypothesis testing. The significance of the path coefficient beta 0.518 shows a relatively high magnitude impact of project complexity on project management quality performance, and as such hypothesis 1 is well accepted in this study. More so, the significance of the path coefficient minus 0.699 shows a relatively high negative effect of project complexity on team absorptive capacity, and as such the hypothesis 2 is also accepted. When the moderator being absorptive capacity was introduced in the model, the relationship between independent variable and dependent variable reduced from 0.518 to 0.21, meaning that there is a moderation, and as such the hypothesis that this moderating construct has the potential to reduce the effect of complexity on quality performance is well accepted as well. To conclude, project complexity can only be mitigated but not eliminated, as it is an inherent characteristic of construction projects. The findings of this study might significantly differ if the moderation is observed without the scope and limitation of this dimension of project management performance. It is recommended on this regard that case studies be carried out to study effect of project complexity on project management performance and the moderating effect of team absorptive capacity within. This brings me to the end of my presentation. I really hope you had a good listening. Kindly refer to the full paper for further details on the structural model analysis. Due to time, I couldn't complete everything. Thank you and have a good conference.